All right, welcome back, everyone. We are live with another baseline show.
Yes, today we have Otto Mora from the Polygon ID team joining us. Sorry, I hear my voice because I have a tab that's not muted. Okay. Thanks for joining us, Otto. I know you've been a guest in our live audience for the last over a year on the baseline show in general, following the work closely and involved at certain stages for certain efforts. And since you moved over to Polygon ID, we've been hoping to have you on soon. So we're really excited to have you here today and to learn more about what's going on there. So maybe you can start with an intro on yourself and then dive into the PowerPoint and content you wanted to share with us, and our studio will ask questions as we go.
Yeah, absolutely. Yeah, Otomora. I'm from Costa Rica. Been working in blockchain since like 2016, thereabouts, and then more full time in around 2018. I first learned about baseline at EY. Like for the original days when it started as an effort there, and I got converted into CK at EY. Became like a full convert. So now my Twitter is a CK identity maxi. It's like the description I have on my Twitter account, because I've become fully converted, and I also love the baseline guys in the community, and I love building in the open and standards. And I also have like my special like magic bus like sticker on my notes. So I'd like to say I'm a baseline OG, but I don't think I'm cool enough yet to qualify as that. But I'll say I'm a baseline fan. Then September of last year, I joined Polygon, and I've been working as the Americas kind of BD contact for Polygon ID, evangelizing around CK identity, getting users, wallets to integrate with us, Web3 communities, DAOs, DeFis that are looking for kind of an identity solution, because the blockchain does need an identity layer, just like the internet does. And so, yeah, I've been working in that space. Maybe I had a little bit of experience from decentralized identity at EY, that's what I get, but I think that I am now fully kind of engaged in that space. And so, yeah, it's this intersection of the three things, like blockchain, identity, and CK, which I think is like really exciting space to be in at the moment. So let me just share, and I can go into some of the, going to my Spotify. Here.
What are you listening to?
I was just gonna say, yeah. What's on?
That's a retro. You know Creed, like the band Creed from like the late 90s, early 2000s. I've been listening to some of their old stuff. Yeah.
Nice.
All right. Well, I'm inspired.
Yeah. Too bad they got split. It's like the usual drama with these bands. Like the singer goes into some substance abuse problem, and then yeah. Okay, let me see. Why is that not? Okay, there we go. So yeah, Polygon ID, a digital trust toolset for Web 2 and Web 3, and we'd like to call it a toolset more than just like a platform, because it's kind of a set of tools depending on what angle of the self-sovereign identity like trust triangle you're in. So it's a set of tools that allows you to do identity solutions for Web 2 and Web 3. So this is more for maybe some of the folks in the audience, maybe they haven't had much exposure, but I believe many of you have. So the self-sovereign identity is this approach, right, for doing digital identity, which gives individuals control over the information, and kind of more autonomy of what information gets shared and to what level it gets shared. So it's creating this concept of a triangle of trust, right? And you have issuers of credentials, you have kind of the users here, where they'll have like some people call it an identity wallet. others just call it a wallet. I think it's like this convergence between the Web3 wallets that we have, which are holding digital assets, with like identity wallets on the other hand. And I can see like the two coming together. You know, it's more and more clear to me that that's kind of the way it's going to go. So you have those credentials in your wallet that are issued by these set of issuers, which could be governments, could be educational institutions, universities, whatsoever. And then you have verifiers, right? And then verifiers will consume these credentials that were issued to you and then use it in some, you know, particular situation, whether it's you're getting your, you know, educational credentials verified for a job application or for, you know, maybe some other use case. That's sort of what the SSI Triangle Trust kind of, you know, it states. And so this model, I think it's even, you know, before, you know, way before blockchain and everything, right? This whole idea of self-sovereign identity has been around for a while. But then I think around 2015, you know, Christopher Allen and others started really kind of integrating both blockchains and self-sovereign identity. And now, you know, I think it's, you know, evolved a bit more, and now we're getting to a bit more maturity. And so like there's, you know, more of a chance of getting real world adoption of all of these like self-sovereign identity standards. So having said all that, which is just more rehashing the previous concepts, if you were very familiar with SSI, the difference between what Polygon ID offers and traditional SSI is that we use ZK proofs to sort of keep your credential data private, right? So you'll have a credential, this credential will have information about you, will have, let's say, your date of birth, your country of residence, other information about that. You'll interact with the verifiers, as was shown in the previous slide, and the verifier is going to ask you a set of questions about your credentials, right? So we have a CK query language that enables you to query these credentials and ask questions about the attributes inside of them. And then when you get those questions, they can be questions in the form of, okay, show me that you're older than 18, show me that you're a citizen of this country, or show me that you're not a citizen of these lists of banned countries, or maybe even more elaborate questions like, you know, demonstrate that your credit score is between 500 and 600, you know, questions like that, right? These credentials live in your wallet. And then so from the credentials, you're able to generate sort of zero knowledge proofs that kind of demonstrate data about those credentials, right? So the zero knowledge proofs are then shared, and then they can be privately verified, right? So the verifier can kind of verify this is a credential issued by a given entity, and I can trust that, you know, if I trust the issuer of it, to be honest, that the data in there is valid, and I don't need to kind of know your full credential data, right? You'll just have a ZK proof about some of the attributes inside your credential. And this is like essentially like, you know, the difference between us and other SSI methods out there, which, you know, even in the case of selective disclosure, you'll still reveal, you know, some of the credential holders data. So that's one of the main differences. And then what that looks like for those of you more into the verifiable credentials world is you have an issuer hand you a series of credentials. These credentials are JSON LD blobs, which have, you know, kind of schemas to them. You kind of hold them in your wallet. There's an element of anchoring these credentials to the blockchain, right? So you never actually per se store the credential data directly on the blockchain, but let's say you store like some indirect hash of it. In our case, it's more of a Merkle tree proof, depending on the type of credential signature that you use. And you then, upon getting questions by the verifier, can generate proofs about these credentials. And the proofs are in the form of a modified JSON web token, JWT or JOT, that we call the JWZ or JSON Web Zero Knowledge. That is how we present these credentials. And this is something that we did in our format, but there's others such as Microsoft working on things such as JSON Web Proofs that are just different ways of doing this kind of CK verifiable credential presentations. So it's, you know, it's an evolving field into kind of standardizing it. So yeah, that's a little bit of how that works. So yeah, main attributes of Polygon ID is, as I showed you, it uses SetK technology to hide information about the credentials. It has a SetK query language. It's fully open source and decentralized, and it's compatible with the W3C spec. It's registered. We've also implemented compatibility with the Decentralized Identity Foundation DIF Universal Resolver. So that's also available there. And a nifty feature that it has is also that it enables on-chain verification. So these proofs that you get and you hand over to the verifier can be used either off-chain, or they could be consumed by a smart contract and then take some action, right? Maybe you show some credential scoring data, and then a smart contract will give you access to, a particular kind of borrowing platform or some other thing that could be useful for on-chain verification. Having said all of that, we don't fully mandate that all interactions use SetK, right? Like that's cool, but you still need to disclose credential data in some cases. So we do allow for selective disclosure of data when required. Especially thinking about some regulated industries such as healthcare or financial services, where you just need the verbatim data. Like, don't give me a SetK proof, like just show me what the data is. So we also enable for that. Some additional features that would be interesting to showcase, I thought maybe kind of separating.
Can I ask a question, Otto?
Yeah.
Do you mind?
Absolutely.
Will you go back to that slide? So I was just wondering, so the user is able to determine what they want to share and what they don't want to share. Maybe this is a dumb question, but on the other side of it, is the one verifying able to also say, like, we want to make sure we aren't given this information? Like, is there a way to limit the information shared on their side as well then?
Yeah, I would say yeah, but more from the standpoint that they explicitly ask for a specific field when they do selective disclosure. So it's not like give me the whole credential, but it's like when you're doing selective disclosure, you're asking for a particular, like just your date of birth, like verbatim date of birth here, like boom.
Okay, so they couldn't add anything else in without. Okay, cool. Thank you.
Yeah, absolutely. So yeah, so the other thing that is here is sort of this concept of splitting keys from identities. And I think, for people that are already in SSI, like this is kind of an obvious thing, a user is not equal to their public key. But I think it's something that we need more in the Ethereum world to start kind of separating out, a user's identity being equal to their sort of, Ethereum key. So we have the concept of kind of managing a set of keys and identifiers, DIDs, kind of being able to control this set of keys. And, you can do things such as key rotation then, right? You can kind of abstract away just the identifier from the key. The other thing which I think is useful is kind of wallets getting into being able to manage several profiles. I think this is an interesting one because, this enables kind of segmenting the interactions you do on Web3 platforms. So the default behavior that we have is kind of privacy preserving in the sense that when you interact with any platform, you always generate an anonymous random identifier. So today I interact with Aave, and then the next day I'll generate another identifier, and that kind of keeps my privacy. But then the user can opt in to be remembered by the protocol by selecting a permanent identifier for their interactions, right? So this will allow you to kind of manage different profiles for different things. So maybe Hedwig can be your gaming profile, and you go into the sandbox, Decentraland, and using that, collecting NFTs. Maybe Patricia could be like your more serious DeFi profile. You go into Compound or Aave, and you're doing other things there. So it kind of segments things out. I think of this very similar to what you have in Google Chrome, where you have kind of different profiles, different Google accounts. One for your work account, could be your personal account. You could be having another one in your nonprofit that you work for or you volunteer at. So there's just different ways to interact. And you have the incognito mode, right? The Google incognito mode, which is sort of this more kind of anonymous default way. So you could say, we almost have the incognito mode as the default mode for Polygon ID. So
quick question, if you could go back. Yeah, so what profile would the beast be for?
Yeah. Maybe just going into Lens and just bashing other crypto networks. If you want to be more just
Solid
using that
answer,
identifier
okay.
for that,
Yeah,
and
proceed.
go into flame wars with Solana folks online and stuff like that. Yeah. So yeah, the Polygon ID tooling that we have is kind of depending on the angle of the triangle of trust, but we have the issuer node to issue credentials. We have wallet SDKs that enable you to integrate whether you're like a mobile wallet or a JavaScript wallet. And then we have the verifier SDK, which I'll show you at the end. There's a set of verification libraries you can use, both for like off-chain verification and also like smart contract templates that we provide for you to be able to consume these proofs. So I'll just quickly show you one of the demos that we have here. I think that will be kind of a useful one. So let me just kind of open this video here and just kind of show you a little bit of that. So this is one of the companies that is integrating with us. We have an ecosystem of various providers, right? But IDeFi, I think, is one of the cool ones. Yeah, I'm sorry, this is not the right one. Let me open the right one. I think it was this DeFi wallet. Maybe it's this credit score issuance. Yeah, so on this one, you'll see sort of like the interaction. You have like a way to kind of set up a compliant DEX. And then they set it up so that it's from this company called Gatekeeper, and you create this new role, and that allows you to set up kind of the first step in the integration. So that's just the setup piece, and then you can create a role and you set certain access controls, and it's let's this user create a new role, require this credit score, and then check for that, right? So this is the setup from the Gatekeeper platform. We're doing some additional checking there based on their kind of workflow. Okay, credit score greater than 600, right? Save that. So this is the setup from the Gatekeeper side. Okay, so now we issue a credential. You can see that there. Describing a little bit more of that. Let me just skip to the other part. Yeah, so now we have the setup there, and then the compliant DEX is sort of the demo platform for that. So in this case, they're doing this example application. Claim your verifiable credential, right? So now you're able to kind of claim verifiable credential here. Right, credit score, credential. And what that's doing then is that you can use this QR code to kind of check for, kind of prove your credentials at that point in time. So it's just a sample demo, but we have a whole bunch of them from various providers that are working on that. So we have sort of a growing ecosystem of companies that are working on that. So we have one of them is IDeFi, as I was showing earlier, in Gatekeeper, but we have other KYC providers such as Fractal, Grail, and others that kind of enable credentials related to KYC. It could be proof of personhood, proof of liveness, proof of uniqueness, other more specific use case such as accrediting an investor, So we have sort of a growing ecosystem of credential issuers, right? And then the other thing around this is around the ecosystem is that we have a growing ecosystem of wallet providers as well. So we provided the Polygon ID app, which is the kind of the say reference application of what we see being an identity wallet. But we also have a set of companies that are integrating with us, including Altme, Verita, Wallet ID, and CLV. And they're integrating kind of our SDKs into their existing wallet. So I think it's pretty cool because like when you look at like sort of like the Altme, for instance, you see the credentials living next to the NFTs. And I think this is sort of where, you know, we see this vision of kind of NFTs and cards being next to each other. And I think this is kind of where Web3 wallets will be going in some sense, being able to manage, you know, NFTs, but also your cards that have attributes about you as well. So that's part of what's happening. The other thing that I think was interesting here was sort of the tooling that we have. So let me just skip to that. So the tooling is depending on which angle, right? So if you're a wallet provider, we have the SDKs, their mobile SDKs in Flutter, and then also in JavaScript. And then if you want to kind of integrate with that, you can do so, right? The JavaScript SDK is also kind of a little toolbox that enables you to issue credentials as well. So it's a little bit even more advanced than the Flutter SDK. If you're issuing credentials, the issuer node is sort of this server that you run in your infrastructure, which allows you to kind of issue credentials, revoke or update credentials, manage your keys. The verifiers libraries as well are available. You can do the off-chain. We have libraries in Go and JavaScript. And then we also have smart contract templates that also enable you to kind of expand on the on-chain verification use case that I was mentioning earlier. So that's available there. I'll kind of show this QR code here as well that kind of directs you to our GitHub repos, and you can, you know, scan that and you can look at our repos and get a look at some of the information there. And then I'll also kind of give you our BD contact for those of you that want to learn more about Polygon ID. You can contact me there. And I'll pause here and take questions.
Hey, thank you. Great job. Just a couple of quick questions. Question number one is like your when you say it's like smart contract templates for VC verification.
Yes.
Are you Merkleizing the VC, and then because it's like it's a you know, as you know, the context files, you have multiple ones, right? You can have multiple context files in a VC. So do you have the different context files like on chain, or are you just simply putting the verifying, sort of like doing Merkle proofs for verification?
Yeah, no, great question. So yeah, so we're sort of Merkleizing the claims, correct? Okay, why did that open an image card? Apologies for that. I just wanted to open it in a new tab, and now it's my default. Okay, great. Yes, I'll try to just use that. I thought I was gonna like just make it a little bit larger maybe here. So we have a set of Merkle trees that we use. And one of them is sort of this claims tree. This claims tree is sort of a private Merkle tree that you use to kind of store all of the claims that you have. And then claims can be in the form of keys that you control or claims about someone else, right? These claims are private, and when you issue these credentials, you're holding this kind of off-chain, right? This root of this Merkle tree is then the sort of one of the elements that is used in what we call the identity state. And so the hashing of 3 Merkle trees is what we do we store it on chain, which is the identity state. And then this revocations tree will hold nonces associated to any of the claims in this Merkle tree. And if you want to revoke a claim, you need just add a leaf to this Merkle tree to indicate that a given claim is revoked. So when you're presenting a claim as valid, you're kind of including the proof of Merkle tree proof, right, which is the sibling path, to show that it is a valid leaf in this claims tree, and then also non-revocation, meaning non-membership of this Merkle tree here. So that's sort of what we have. But yeah, these claims are kind of offline, and you hold that privately as an issuer of credentials.
Right. No, I understand that. So this is the revocation tree is a sparse Merkle tree. So it's like that's fine. And then that's the claim tree root. So that's the history, right? Because it's a root tree, the third one.
Yes, you can rotate it out as you get the historical state of these Merkle trees, then the root tree will
Right.
hold that. Yes.
That's right. It's just like what you do with in like ZK rollups, where you have a state tree, where you have a node tree, a nullifier tree, and a root tree, right? So my question was, so an individual credential, right?
Yes.
So a leaf in the claims tree, right? That itself is a JSON LD object.
Yes, that itself is a JSON LD credential.
Right.
That.
So
Yeah.
so if you verify that, so what you're verifying on chain is only that the claim exists and hasn't been revoked. Correct?
In a given, those are the 2 of the base proofs that you would do, and then the
Right.
additional proof is a given information about that credential. So one of the attributes in the credential is greater than a given value, or maybe not equal to a given value. We have a ZK query language that enables you to ask questions about these proofs. And so that's what we have here. Let me show you quickly. Yeah. So, are you equal to a value? Is a given value less than another? Is it greater than another? These are the set of operators that you can ask about the credentials. Yeah.
Okay, so again, let me just like back up here for a second. So when you're saying credential verification, right? So typically in a credential verification, you're checking that the credential, that the schema matches the claim contexts, right? The schemas that are in the context, and then you do the cryptographic proof by verifying the proof property, right? And then you can add additional checks if you want to, whether certain value in the credential subject are larger than or smaller or equal to, or of a or a string or whatever, right?
Mm-hmm.
So
Yeah.
the question is like doing that on chain is like, it's like you would have to have like all the context files. Correct me if I'm wrong, what you're doing, you're actually creating zero knowledge proofs for the credentials, right?
Yeah. We're creating zero knowledge proofs from as snark from the credential data, exactly, from the
right, which
JSON.
is a predicate that says, so you're Merkleizing it, and then you're doing proof inclusion for the yes, all the elements are actually in that. So your public input is the root hash of the entire tree, which is a is the Merkleized version of the JSON LD, and then you're doing checks on values, right?
Yeah,
Equal
yes.
to, larger, less than. So what you're generating, what you're then sending on chain, what you're verifying on chain is just you're sending that to a verifier contract that just verifies the snark, correct?
Yes, correct. Verifies the
Right.
snark. Yeah.
Right. So where do you actually? So is there a registry of types, right? That you're verifying that this is the correct type, and that you're checking, the values in that. What I'm sorry, it's like, it's not. Where's the predicate information, right? So that I know that what I'm verifying is like, is that this is a driver's license, and that the person is over the age of 18 or 21, has a valid US address, right? And it hasn't been revoked.
Yes. So yes, that check is there. The part that and I will acknowledge that that's not there is the sort of the credential schema check that you mentioned. Because
Right.
in this case, I mean, you're right, exactly. Like the credential itself, the schema is actually not on chain. So yeah, I would recognize that that's not there. But then yes, if you can presume enough about the structure of the credential, then the proof, the predicate can be validated. And yes, we have the smart contract here that kind of checks for that. What you described, like in this case, it's a particular check to see that the user has a birth date that is born before this date, and then if the user is able to prove that they were born before that date, then they get like the ERC20 airdrop in this case. So yeah, this is just a sample one, but yeah, because you can see here the credential schema is off chain, right? So I would concede that yes, you do have to, in this case, trust that there is some existing structure to the schema that you're complying with. Yes.
Right. That's the big problem, because you need to have a schema, because that's what you do at the very beginning, right? You're checking whether the credential you're verifying, is compliant with a given schema.
Yeah.
Right, because
Yeah,
otherwise you don't know.
Yeah.
You don't know, right? So otherwise it's like, oh, there's a credential, great, and it says that this guy is over 18, and it has a valid digital signature from an issuer.
Yes, correct. Yes, in this case, you're more relying on, is this an issuer that I would trust, right? Is this an issuer that I know has a reputational factor to it that gives me the trust? But yes, correct.
Right,
That could be
and uses the right schema, and uses the right schema.
Yes.
Right.
Yeah, exactly. That part, in fact, we don't have at the moment, but I think that's a great addition. Checking for the right schema, and then if the schema is on chain, then that becomes a possibility. Yeah.
Yeah, that was my only thing. This is great. Now you can do like compliance check that we said for compliant dexes, even though now you have multi-hop processes, right? It's not like, right, because you basically have to have like field versions of assets.
Yeah,
Unless
exactly.
unless that asset is born a compliant asset.
Yeah, exactly. Yeah, exactly. Unless it is from the get-go implemented as a compliant asset, then yeah. I mean, there's several challenges in this, right? Because you do need to kind of incentivize users to do the KYC checks. We're trying to get into the concept of the reusable KYC and avoiding having the user to go through that constantly. So yeah, so there's more moving parts in this now, because we also have to sort of influence the Web3 wallets to adopt the Polygon ID protocol. So yeah, there's some moving parts to it, but at least it's a starting point, that it's sort of, this open source base you can build from.
So the wallet supports both ECDSA and EDDSA, right?
Yes, exactly. Wallets would support both ECDSA for a set of limited functionality around Ethereum keys. But that's not something that is ready now, but it will be in the coming release. And for EDDSA, it uses baby JubJub keys for proving information about the credentials. So yeah, for now it's more on the baby JubJub keys for generating proofs about the credential data.
Using the baby JubJub curve to generate Schnorr signatures.
Snarks, yes.
No, well, no, the digital signature, right? You want this to be small.
Oh, yes.
So you
let me.
So you want to do it like you want to do a Schnorr signature, right? EDDSA uses Schnorr signatures, right? That's why you do it, because you can get away with a much smaller signature size, which means you need less constraints for
You're probably
verification.
Yeah, you're probably right. I'm not that deep into the type of signature that the BJJ does, but you're probably right. Yeah, all I had here is that K-Snarks with G16 and that particular proving scheme. But yes, you're probably right. That's probably.
Yeah, no, it's a pairing friendly. Baby JubJub is just a pairing friendly elliptic curve.
Yeah,
like Grumpkin, what Aztec uses.
Okay. Yeah, and I think part of the reason for this was being able to generate proofs from mobile devices and kind of optimizing around that. So we have like the Rapid Snark library, which is helping with
Rapid Snark, right?
Yeah.
So you're using, so your hashing that you're using in the ZK pieces are Poseidon hashes.
Yeah.
Cool. Yeah, sorry, I haven't looked deeply into that. It's like I haven't just had time to do a technical deep dive into Polygon ID. So that's why I'm like asking these stupid questions.
No, not stupid at all. Very good questions to keep me on my toes.
I got a couple of questions. First one, what does the verifier user interface look like? I know that a lot of attention whenever we really kind of showcase the idea of self-sovereign identity, and this particular one, when you have decentralized ID, it's all about wallets and how we can go ahead and do our proving schemes. What does the verifier, it's 2 a.m. I am, into my 6th martini, so I'm probably, having a good time and everything. And so I want to get into this club, the doorman. I've got to prove to him I'm at least 21. What does it look like on his, device or whatever saying yes? Has anyone kind of looked at that? Because again, it is a it's a kind of a mini ecosystem. So I'm just wondering what it looks like from that to where you've got, say, a bouncer having to deal with somebody who's a little, maybe a little overserved, that evening and stuff. Like, yeah, here, I'm 21.
Yeah, are you asking if it can prove how drunk you are as well? After 6 martinis?
I'm just saying, given the conditions where you would have to actually have that proof function, it might be, late at night, and yeah.
They may have zero knowledge, but not of the ZKP kind, right? It'd be a different kind of zero knowledge.
Right, right.
So
Good.
yes, yes, yeah. So yeah, and I recognize that the previous demo wasn't the best. I just sort of I had it open and I don't know why I didn't open the right one. But so after the claims are in your wallet, right? You're looking at the set of cards, and these are the cards that I was showing you in the Help.me wallet, with this idea of you having a NFTs next to your cards. And so, oh, why did it stop sharing? Wait, 1 second. 1 second, something just happened here.
It's fine.
And,
We're all disappointed that you're not also playing Creed for us, but we'll forgive you as you.
It's just the
Or to get the other
copyright for
info.
the stream, you know.
I think my browser just died on me. Oh my gosh, like it just bombed. Chrome just bombed. Oh, so disappointed, Google. All right, give me a second. I'll reopen my browser. But yeah,
Not a problem, but yeah, that was the one thing is start looking at all of the different personas that are going to be in the proof exchange, proof
Yes.
verifier, type thing. Issuer, again, if it's something that's going to be a regular, normally recognized credential, I mean, certainly by a government entity by like a passport or a driver's license or a state issued type card, but you're going to have other types of ways of proving your identity, in different ways. Some people would say, hey, I don't have my driver's license card, but I've got my concealed carry permit. Will that work? It's government issued and it has an expiration date. It has my photo on it and all of my different attributes. But you'll have a lot of people going, yeah, but I'm not going to accept that as proof. And it's like, well, why not? And that's where you get into the the weeds, is starting to see what it is. But what are you proving, and what does it look like for the verifier to say, okay, yes, I have done this, I have done my due diligence, I have had my reasonable level of care to make sure that I have made sure this person is compliant, and so I'm going to go ahead and allow them to access. So I was just wondering what would that look like on the verifier side?
Okay. Thanks for that. That helps a lot with yeah. So at this point, you would, as a verifier, choose a list of credentials issuers that you trust, like to your specific, like, a age of majority type of example. And then, you say, maybe I'll trust the government of North Carolina and this other set of entities to give me these, valid credentials. So those issuers are registered in an on-chain contract, and you can sort of check that it's on chain. Let me maybe even open that just quickly. Credential anchoring, I think it was called. And that's the one that has the detail on that. So just give me 1 sec to flip to that slide. So you have this list of issuers in this smart contract that have registered their identifier, and you would pick which of those you trust. And then from then on, you trust that these issuers will issue credentials about that user that are trustworthy. And then a proof from that credential is what you consume, essentially. I don't know if that helped.
Well, yeah, I mean, I was just sitting here looking at, okay, you want to make this interaction as low overhead as possible.
Yeah.
And just say we're doing it on phones. I'm the prover. I just need to give you a range proof I'm over 21. And you're the verifier. You want to come in and sit there and say, yeah, has he proven to my standard of care that yes, it is. Meaning that should he have some fraud, I'm actually really 19 and trying to get in, that it's not gonna come back and bite me.
Right. As long as you trust, like the key assumption, right? And the interaction, yes, looks like this, like when you log into the website, it's like, in this case, it's like prove your eligibility to vote in this DAO, right? For instance. So you would scan that QR code and then it's asking you to prove a given information about your credentials. The key assumption underneath all of this is that the issuer of the credential is someone you trust. Because otherwise it's garbage in, garbage out, right? So that's the key underlying assumption when you're generating the ZK proof, that it is somebody that you would trust would be honest about issuing a credential.
Right.
So then you can trust the cryptography to do its job. Yeah, sorry, go ahead.
Yeah, so in the thing, I basically said here, I'm walking up, I pull up my verified credential, which gives a QR code, hold it out. The guy will then scan it. And what does he, does he get a thumbs up or down? Does he get a true, false? Does he, I guess my original question was, what does that look like from the verifier side?
Oh, okay.
We have so much attention on the prover side, like, hey, this is what this wallet's going to look like. But when we go ahead and push through the paces and say, hey, what does it look like on the verifier side? So does he hold it out? Does it, that's my original question. Sorry, it took a while.
Oh, okay. No, now we're really digging into it. Yeah. So I don't have a demo of that, but it could look something like that, where you're at a traffic stop and then, there's like an NFC exchange or like a Bluetooth exchange, and the cop just gets like a thumbs up or green check on his phone to say, yes, this is, and that would be possible with our protocol. So our protocol is flexible enough that you could do it over Bluetooth, you could do it over NFC, you could do it over HTTP. It uses a flavor of something called DITCOM that enables that interaction to take place. Yeah.
Yes. Okay. Second question that I had was on the transaction management. Ultimately, this is done on Ethereum, which has a cost. And how is that allocated for? Do I have to, go ahead and get some ether and load it on there? And who actually manages that? And how's it done within the, I guess, the stack?
Yes, absolutely. So there's two ways to issue credentials. One of them is something we call the SIG method. And what that does is it allows you to just sign the credential and sort of like with a BJJ signature. So all you need to do to use this method is that you would sort of publish your initial issuer state on chain. And that's just registering your DID and your issuer state, which is this hash of Merkle trees and these other things.
Right.
And then afterwards, it is gasless to issue credentials. Like you can just issue, millions, billions of credentials. And as long as you're not revoking any of them, you wouldn't be doing anything on chain. So this is probably going to be the more popular method of issuing credentials, right? Because it would just allow you to just massively issue credentials, right? So that's one way. And then the other way, which is the other method that our DID method allows for issuing credentials, is sort of the MTP method, which is the Merkle tree proof method. And in this one, not only are you signing the credential with the baby JubJub signature, but you're also adding it to this on-chain issuer state. And so at that point, you would modify your on-chain issuer state, and that does involve kind of gas costs, right? So this one we believe will be more interesting for allowing smart contracts to issue you credentials. So I could look at your on-chain activity, maybe you've been paying your loans on time or in Compound or Aave, and I can give you like a credit score credential or something like that.
Okay.
But yeah, this one would be a bit more oriented towards smart contract issuing credentials. We believe the BJJ method, which is the signature, will be the more popular one.
Awesome. Any other questions from the group?
I have a general question. And also I love the names that we get to talk about, like baby JubJub. I mean, what other industry do you get to use words like this? It's fantastic. But I was wondering, what do you think the largest hurdle to adoption is? Like of self-sovereign identity, but then also Polygon ID? What are the challenges right now?
So I believe it's wallet adoption, one of the key ones, and then the other one is sort of verifiers starting to consume credentials, because there's a tendency to just like rely on these NFTs and soulbound tokens at the moment, and somewhat effective, but like I think long term, it's not very privacy oriented. Like it doesn't like really preserve your privacy. So yeah, I think those are the two things where I see, getting more wallets to adopt the protocol, and then verifiers to start just, getting into reusable credentials as opposed to trusting these NFTs on chain.
Cool, thank you.
Any other questions?
No, but I will say this was
Going once.
fascinating. It was very interesting getting to hear directly from you, Otto, and looking at this. So thank you.
Well, thanks so much, and thanks for bearing with my Google Chrome misbehaving.
Oh no, I'm listening to Creed
Solid.
all the rest of the day, just so everyone knows.
Yeah, it worked out.
Nice.
Yeah, thanks for walking us through that and starting at the high level and getting into all the details. Lots of great slides and content you were able to show as you answered every question, and demos and things. So it was super interactive and engaging. Thanks for joining us. Is there anything from the baseline side that we want to mention in regards to the identity aspects of the protocol and how something like Polygon ID could fulfill those? Keith, Yoav, the other devs, I know that was recently mentioned in the interoperability chat, but could you give a little more context on what the potential alignment would be there?
Yeah, so
for me,
far,
go ahead. Yeah, go. Keith.
yeah. I mean, if you want to take the question,
No.
and then play us out
I'm
with some
good.
Creed, that's fine. Yeah. No, actually, I mean, so far we haven't really gone in depth. So the easy answer to your question is we're trying to seek alignment in creating, the BPI interoperability between the two different BPIs on just the initial question of, do we even need to have alignment on, what type of DID method we're using, and then to go on one step beyond that and decide, if we do, then which one, and if not, then also still which one are we implementing on our side, and that the interop, the other side of the BPI is implementing. So we're still at a very kind of initial stage, right? But Polygon ID is up there in the running.
Yeah, I mean, couldn't we just use Polygon ID as the identity? It's like just the SDK integrating that.
Yeah, that could be.
I don't see why
Hard to
not.
argue against that.
Yeah.
Let's do it.
For the
Decided.
simple reference implementation, and we can still use the JWT for the authentication, right? I mean, that's easy. It's just has a you're supporting that, right?
Yeah, the proof is a modified JWT, and yeah, you could probably just adapt it to your particular.
I mean, yeah, you said you had the
it-
ability to not include the zero knowledge portion, so we could selectively include it when we wanted and we did not. So that could also double for whatever we use for authentication here.
Yeah, that could be. Yeah, selective disclosure is sort of like this additional method that we provide. At the moment, it has a restriction that you can only reveal a single field and not like a set of fields. So there's that key watch out there, but we're working on ways to either, give you the full credential, but that wouldn't be very privacy preserving.
I'll disclose the schema field.
Well, there you go. Disclose the schema field. That's kind of cool. Right? It's a good idea. Or like offer at least more more fields. The thing is, like, we only offer the single field because you're also generating a ZK proof. So if you do too many fields, then you'd be, you know, kind of waiting on your phone to like generate the ZK proof for like a minute, and that's not very usable.
Yeah.
So,
I mean, even further beyond that selective one, didn't you also say that there was a, you could like turn on and off even the ZK part of it, right? Or
not
No,
yet.
I
It
just-
hasn't been implemented, but
Okay.
we're wanting to
Okay.
to offer something around that. Yeah, we're as much as I like to be a CK maxi, can't be a solution to everything, right? So
No, it can. I am too. Let's ZKR authentication protocol as well.
Well, I love that too, because, you know, it's like this idea where people are like, oh, we can use a blockchain for that. Why? The same thing, like sometimes you don't need the technology, use it where it makes sense and don't use it where it doesn't make sense.
Gee, that's how baseline got started. In a nutshell.
Is it?
Yeah. Quit using it as a dominant big fancy database or a dominant piece of the architecture, which is contemplating displacing the ERP or the CRM system. And you know, why not use it for, you know, as middleware? You know, that root of trust, not that single source of truth. You know, because the single source of truth, people don't want another digital nudist colony. I don't need to, much less want to see what everybody else has.
I'm loving it. I'm getting a lot of Wolford vibes here now.
Yeah, it's totally ripped.
I love it.
Yeah, right on.
Awesome. All right. Well, we came full circle with that conversation. Otto, we hope to have you and the Polygon ID folks involved in some of our conversations in progress about the upcoming interoperability. So I will be in touch with you on that. And thanks for joining our baseline show. If you ever want to do a round two, please let us know. And as always, you're welcome to join our weekly streams. Thank you to our live audience for engaging in the discussions as well. And we will see you all next week. Thank you.
Yeah, thank you, everybody.
Bye. Thank you.
Thank you.